now let's get going. Okay, section 3.1, mean, median, and mode. The first thing we're going to look at is a way to order data. If you have a long list of numbers like over here, 16, 45, 36, 18, and so on, they're out of order and you need to get them in order. One way is to use a stem and leaf plot. Now the stem is the front number, like on the 16 here. The 1 would be the front number. So you're going to make the stem 1 right there. And then the leaf is the 6 from 16 right there. Then you go through the list. 45, which is currently covered up a little bit. Well, you'd use the 4 as the front number and then the 5 as the next number. Then 36. Well, 3 is the stem. 6 is the leaf. And then you go through the list again. 18, well, stem is 1, so it goes in the category right next to the 6 here. 8. Now, do that through the whole list. Take a minute and do that all the way through. And you'll notice 105 over there eventually. That stem would then be 10. And then 5 would be the leaf for that. By the way, when I did this originally, I forgot, or I didn't notice at the end here that I have 3. Well, there's no front numbers, no stem, so 0, and then 3 is the leaf. After you do that, you can quickly put things in order. If you want to use a chart, like over here, go ahead, do that. You know, the 3 would be the front number. But then within each one of these stems, all of these teen numbers here, put them in order. Now you have a shorter list to put in order. Okay, I can see right away 12 is the first number. So the 2 comes up. Then the 6, then the 8, then the 9. So quickly you can make a list. 3, 12, 16, 18, 19, and so on. One thing to remember too is that sometimes some numbers are repeated. For example, the number 45 is repeated a couple of times in the list. 45 there, and 45 is the second number as well. Make sure you list each one of those both times, right there. Because when you do your list in order, you actually want to make sure you list both 45s in there. Now, pause the video, make sure you can do the stem and leaf plot yourself. Don't fool yourself and just copy this down. Put them in order, and then you can compare them with what I've got right here on the right-hand side of the margin. 3, 12, 16, 18, 19, and so on. When you get that done, we'll take a look at arithmetic mean. So pause right now. Okay, I'm assuming now that you've worked through that. Now, what's an arithmetic mean? It's what you normally call the average in everyday language. We use this X bar symbol to mean the mean. Now the mean is a specific type of average. Average can mean other things anyways. And the formula for the mean is X bar is equal to, the mean is equal to, the sum of all these numbers here divided by the total number of values in there. In this particular case, if you add 7 plus 2 plus 4 and so on, you're going to get 33. And there's 10 numbers. Go ahead and check that out. Then you just use your calculator if you can't do it in your head. In this particular case, 3.3 is the mean, that type of average. Okay, make sure you can do that and you understand that. The next thing is sometimes you can use averages in a different way, or means. What if you want the mean number to be 35, for example, here? That's what this problem is like, so 35 yards. Let's read through this. In one game, a football team has offensive drives of 45, 43, 24, 21, and 44 yards. Now, the coach wants the team to have an average, or mean, this particular type of average, of 35 yards per game. And he wants to do at least one more offensive drive. So what must the length of the next offensive drive be if he wants to achieve his goal of a 35-yard mean? Well, let's take a look. The formula in here in black is x bar is equal to the sum divided by the number of values. We don't know what the last or sixth value will be. And that's what you want to solve. Now, the average, the mean, is going to be 35. That's why I've used this color to match what I underlined here. That's the answer. We already know the other 5 drives, 43 plus 40, or 45 plus 43, 24, 21, and 44, add up to 177. Check it out. You don't know what the 6th drive is going to be, but you're going to find that out right away and solve for it. And there's going to be 6 drives in total, so that's why we divide by 6. That's the number of drives. Now, how do we solve for x? Well, if you're going to isolate x, the first thing is you got to get rid of it. So we're solving for this x right there. The problem is we've got division here, dividing by 6. The opposite of dividing by 6 is multiplying by 6. Do the same thing to both sides, so we're going to multiply both sides by 6. So I just put this here. 6 times 35 on that side, but the real important one is 6 times on the right-hand side here. That will get rid of the 6 on the denominator, the blue 6 there. I'm just going to grab this here. If you multiply by 6, you get rid of the 6 on the bottom. That makes that side way easier. And then on this left side, 6 times 35, well, you do the arithmetic, you'll get 210. So this is the new equation. It's way simpler to add, or to figure out. The next thing you do is to get x all by itself. If it's 177 plus x, let's get x by itself by subtracting 177 from both sides. When you do that, the arithmetic tells you 33 is what the value of x is. So then make a statement. The next drive should be 33 yards. Now there's a new concept too. Average could mean median or mode in some situations. They're all called, mean, median, and mode are all called central tendencies. Take the time to read through this here. And a few things about the median. If you list things in order, it's the middle value. We'll take a look at some examples in a second here. And the mode is the value that is repeated most often. Now, you might have one mode in a set if it occurs more than anything else. It's the most occurring thing. But sometimes you can have 2 or more modes if there's a tie for first place. If there's nothing ever repeated, there is no mode in your set. Okay? Now read through this, take some time, pause it if you need. And let's work through an example then. Calculate the mean, or not the mean, the median and the mode for the following data sets. Now set A isn't in order if you take a look at this. Take some time, put it in order. I have this one put in order already. Now the median is the middle value. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. So what's the middle of 15? 7.5. We're going to round that up and make it 8. And the 8th value, because they're listed in order, is 1, 2, 3, 4, 5, 6, 7, 8. That means that there will be 7 below it, if you count there, and 7 above it. 33 is the exact middle of this set. So 33 is the median value. The mode is the most repeated. Now 32 is repeated twice, but the most repeated is 45. It's repeated 3 times. So that is your mode in this set. Okay. How about the next set? B, 11, 3, 16, and so on. There we are. We put it in order. 3, 11, 16, 29. You'll notice there's 8 values, and half of 8 is 4. And when you do that, I put this blue line here. There's 4 values to the left, there's 4 values higher, 4 values to the right. There is no actual number right in dead center. So you've got to say between these two values, 29 and 31, what is the middle of those two values? Sometimes the values, this one is easy to see. The middle number between 29 and 31 is 30. If you can't see that though sometimes, because the numbers may be decimals or a lot farther spread apart, add the two numbers up and take the mean value. So 29 plus 31 in this case is 60 divided by 2 because you're taking the mean of two values, and you got your 30. So 30 is the mean. By the way, there's no mode here. Nothing is repeated ever. Okay. Now, I've left this example here for you to try, and of course you can try your assignments here too. Working with negative numbers is no different. Just add them up, positives and negatives, and so on, okay?